friends, hello everyone, welcome back to Pocus Pulse, brought to you by ARDMS Academy. I'm really excited that you are here again with me. Thank you for being with me. I'm Dr. Abdul Qadir, emergency medicine specialist. Today we are diving into one of the most important and surprisingly fun topic in ultrasound physics. It's about sound waves personality. So you are going to talk about sound wave personality. It's a very interesting topic for me. I'm sure that we will find it easy and interesting also at the end. You know, physics might sound intimidating for everyone. Even for me, it was very difficult and confusing at the beginning when I decided to study about the ultrasound physics. But don't worry, I'm here to explain everything in a way that actually makes sense for you. We will explain step by step and even a little fun. So if you are prepping for any exams or if you have an interest to learn more about ultrasound physics, trust me, you're in the right place. It is a must-watch video that you can use it. Just let's start it. We will explain everything very easily and we will learn together. Thank you. Alright, let's break this down in simple words. Today we are talking about the basic of ultrasounds, the sound wave itself. Think of it like learning how the ultrasound machine talks. So it can see inside the body, and you know, every picture that you see during an ultrasound comes from how the sound wave behaves. That's why it is so important to understand them. There are 7 things or parameters that can help us describe how these sound waves work. And I know it might sound like complicated science, but don't worry. We will explain here in an easy way. Whether you are just starting to learn ultrasound or studying for any exams, I think this will help you. We'll also talk about why these things matter in real-life ultrasound practice. How do they change the picture, and how can knowing them help you to use the machine better? That's what we will find out together. So the 7 important sound wave parameters, like sound wave personality characters, are period, frequency, amplitude, power, intensity, wavelengths, and propagation speed. You know, you can think of them like a different feature of wave. You can group them into 3 parts, like some of them, so they are talking about the timing, like period and frequency, and some of them like amplitude, power, intensity. It is related to the strength of the wave, and also some of them like wavelengths and propagation speeds. It's about the movement. So let's begin with timing. Firstly, we will talk about the period and the frequency firstly. Okay, so let's talk about the period. The period is the time it takes for one wave to finish one full cycle. Just picture jumping on a trampoline. You go down, bounce up, and come back down. The whole bounce is one cycle. In ultrasound, the time is very, very short, measured in microseconds, which means millionths of a second. Usually it's between 0.06 to 0.5 microseconds. So it's very, very, very short time. You know, during the scan, during the ultrasound, you cannot change the period. And if you wanted to change your period, you need to change it before starting your scan. I mean, you need to change your transducer. So it depends on the transducer and the probe and the machine. So the sonographer cannot adjust the period. The period is absolutely related to the what transducer that you are using. So now, let's talk about the frequency. Okay, so we talked about the period. Period was time, the time it takes for one wave to finish, like one bounce in trampoline. It is one cycle. So it was very short time, like a millionth of a second. That's why we are using microseconds. About the frequency. Frequency is how many wave cycles happen in 1 second. How many times you can jump from, the trampoline. It is like a cycle. It is like a cycle. So it is the frequency. It measured in hertz in ultrasound, but we use a megahertz. Why you are using megahertz? Because you know there is millions of cycle per seconds. So most ultrasound, they are using between 2 to 15 megahertz. Even some of them higher frequency we use in them, like a 20 megahertz. It depends on what kind of ultrasound that you are using. I mean, for example, if you're not using the ultrasound for assessment of like superficial or shallow organs, so we need to go to so some kind of megahertz frequency. But if you wanted to have assessment in a depth, so we need to have another kinds of probes, transducer with lower frequency. So we will talk about it later. Just like a period, so we thought that we cannot change the period during the scan. Also for the frequency, you cannot change the frequency during the scan. If you wanted to use a different frequency, different the period, you need to change the probe or its setting before starting. So during the scans, the sonographer cannot adjust the frequency and the period. A period and frequency, they are connected to each other. There are reciprocal. So we will talk about what type of relationship, what sort of connection period and frequency they have. Okay, so we talked about the period as a time. It was like microseconds, and we talked about the frequency, how many cycles happen in 1 second, like megahertz, and we thought that the frequency and the period are connected to each other. So what type of connection, what type of relationship they have to each other? They are reciprocal. What does it mean? Means when one goes up, for example, if the period goes up, the frequency goes down. Or, for example, if the frequency goes up, the period goes down. So they are reciprocal. Means if you multiply them together, for example, period by frequency, always the answer should be 1. For example, if the frequency is the 5, the period is in flip side of the frequency. So it is 1/5, saying like 0.2 microseconds. So why this important for us? Because we should know which type of frequency, which type of transducer we wanted to use. If you are using high frequency, so the machine gives you a better picture quality, more details, the best resolution, but it doesn't go deeper into the body. So if you are to scan something in depth of abdomen, like a liver, like a spleen, like aorta, so if you are using high frequency, so the high frequency doesn't go too deep into our body. So what type of frequency we should use here? Lower frequency, because you want to go deeper, but the images is not that sharp that we have in higher frequency. So as a sonographer, you must choose what you need more. You need more details or you need more depths. Depends of your goal, your aim. You are using the best frequency, the best transducer. So if you wanted to have a more resolution, more detail, like a checking thyroid, checking like musculoskeletal skin like that, so we need to go to higher frequency, even sometimes 15 if you wanted to check, for example, skin. But if you wanted to check some organs in depth of abdomen, like liver, as we discussed, or bladder, or any organ, intraperitoneal organ, so you need to go to for lower frequency because you want to go to the deeper. So we will choose which type of transducer, which type of frequency we need, and we use them. So this is like a balance between details and depths. Okay, so let's move to the strength part. I mean, amplitude, power, and intensity. These tell us how strong the wave it is. Amplitude, what is the amplitude? Is how tall the wave is. Think of water in the ocean. The higher the wave, the more powerful it is. In ultrasound, amplitude tells us how strong the wave is at the highest point, at the peak. How we can measure from the baseline to the trough or to the peak. It is the amplitude. It can be measured in different units. Depends on what type of measurement that you are using. For example, Pascal is for pressure. So if you wanted to check amplitude for the pressure, so the Pascal is the unit. But if you wanted to check the distance, the movement, centimeter it is. And if you wanted to use some relative scale, decibel, it's the unit for amplitude. You can adjust the amplitude using the gain or power control on your machine. So the sonographer can adjust amplitude using the gain and the power control. That we will talk more about it in next episodes. Remember, there is a golden rule, there is a very important rule that we should keep in our mind. As the wave moves deeper into the body, the amplitude gets weaker. This is called attenuation. So what is the attenuation? Getting weaker when the wave moves deeper into the body. That's why the resolution gets weaker when you are using lower frequency. So we should remember always these rules. The amplitude as a character of the wave gets weaker when the wave moves deeper. Okay, let's talk about the power. Power, it was the second character that tells us how strong the wave is. So what is the power? Power is amount of energy the wave carries every second. It is the power. Power, so it is amount of energy the wave carries every second. It is measured in watts, like a light bulb. You can adjust power during a scan also. So the sonographer can change the power during scanning. Here is very important rule that we need to keep in our mind. What is the relationship between the amplitude and the power? Power is proportional to amplitude square. What does mean? Means if you double the amplitude, the power becomes 4 times stronger. You know, it was proportional to amplitude squared. If you triple the amplitude, the power becomes 9 times stronger. So small changes can have a big effect. Okay, let's talk about the next one. It is intensity. What is the intensity? Intensity means how focused the power is in one small area. Think of using a magnifying glass to focus sunlight. If you focus it in a small spot, it can burn the power. The power is the same. We didn't change the power. We just focus it in a small spot. That's why we can burn. You can burn a paper. Intensity works the same way. It measures in watt per square centimeter. And also something that you can change it. So we can, as a sonographer, change the intensity as we can change the amplitude and the power. And just like a power, intensity increases a lot when amplitude goes up. What type of relationship between the intensity and the power? They are directly related to each other. If the power gets the double, the intensity will get double. But if the amplitude get double, the intensity and the power, each of them, they will get like 4 times stronger. So the relationship between the intensity and amplitude, it is intensity is proportional to amplitude squared, same as the power is proportional to amplitude squared. Okay, so we talk about which parameters describe wave strength. There are 3 bigness parameters: amplitude, power, intensity. All of them tell us about wave strength. They start from the machine, but we can adjust them. So the sonographer has a control over them during the scanning. They can increase and they can decrease them during scannings. They get weaker as the wave goes deeper into the body. So the intonation is related to the amplitude, power, and intensity. They will get weaker when the wave goes deeper into the body. Okay, let's move to the next part. Let's talk about the last 2, wavelengths and propagation speed. Firstly, we will talk about the wavelengths. What is the wavelengths? Wavelengths is the physical length of one wave. Think of a train. The wavelength is like the length of one train car. We usually measure in millimeters in ultrasound. wavelengths depends on both frequency and the medium. You know, the frequency related to the transducer, related to the probe, related to the machine. And the medium is the soft tissue the wave is moving through it. As a sonographer, we cannot change wavelengths directly, as we cannot change the frequency, you cannot change medium during the scanning. There is a formula for wavelengths that you need to remember. Lambda equals speed over the frequency. In soft tissue, we have a shortcut. Wavelengths equal 1.54 over the frequency. That's because sound usually travels at 1,540 meters per second in soft tissue. So it is a shortcut formula that we need to remember. Why does this matter for us? What is important for us? You know, shorter wavelengths give better image detail. And you know that higher frequency gives us shorter wavelengths. So per the formula, the wavelengths is related to frequency, but inversely related to the frequency. Means higher the frequency, we will have shorter wavelengths. And we discussed it before that with higher the frequency, we have better resolution, more detail, sharper image. So that's why we say shorter wavelengths means higher the frequency, and it gives us better images, more detailed, sharper image. Okay, next move to another one, to next one, propagation speed. What does mean propagation speed? This means how fast sound travels through different tissue. It is measured in meter per second. And this speed depends on only tissue, the medium, not the machine and not the probe. Ultrasound machine always assume the sound travel at 1,540 meters per second in soft tissue. But in real life, the speed is different in different tissue. For example, sound travel much faster in bone and much slower in the air. This difference can cause image error and artifacts that we should know about them. Two things decide the speed: stiffness and density of the tissue, that we will talk about them. Okay, so we talked about propagation speed, and we talked about the things decide the speed: stiffness and density. But what is the stiffness? What is the density? Stiffness means how hard it is to press the tissue, and density means how heavy or packed the tissue is. How we can remember them? It's very easy. More stiffness, faster speed. S and S go the same way, and more density, slower speed. D and S go different waves. But stiffness has a bigger effect than density. That's why sounds travel faster in bone. It's very, very stiff, but it's very, very slow in lung, as the air is not stiff at all. Okay, well done. We already talked about all the parameters: period, frequency, amplitude, power, intensity, wavelengths, and propagation speed. Right now we know that period and frequency set by the probe, and we cannot change them during the scanning. So the sonographer cannot control period and the frequency. Amplitude, power, and intensity, it is about the wave strengths. Start from the machine, but as a sonographer we can change them, we can adjust them using the power and using the gain. Wavelengths depends on both the frequency and the tissue. So the wavelengths depends on the probe and also soft tissue or medium. But we cannot directly adjust them, we cannot change them during the scanning. And propagation speed depends only on the soft tissue, only on the medium, and we cannot adjust them, we cannot change them during the scanning. So we have some formula that we need to remember them about the period of frequency. Always period by frequency is equal 1. Period and frequency are at the flip side of each other. The power is proportional to amplitude squared, and also intensity is proportional to amplitude squared. Power and intensity, they are related to each other, they are linked to each other directly. Like if the power gets double, the intensity will get double also. The wavelength is equal to speed over the frequency. So the wavelength is inversely related to the frequency, means the more frequency, the shorter wavelengths. Knowing these basics will help you to choose the right probe, improve your images, and use the machine safely. It is all about understanding why sometimes we have some artifacts, and how we can improve our images and how we can interpret the images in the best way. Okay, now here is something to think about that. How would different tissue like a hard tumor or a soft fluid filled cyst affect the speed of the sound wave? If you think about the stiffness and the density, you can already guess how the wave behaves before even image forms. That's why we can say how physics connects to the real-life patient care. Once you understand the wave, you can understand also the images. I believe this knowledge really elevates our practice from just following protocols to truly understanding the why behind our actions. Physics, image, safety, they are all linked through these pyramids. Thank you so much for joining me today. If this helped you, please hit the like, subscribe, and share it with your friends. You've got this, and I will see you in the next episodes. Keep scanning, keep learning, take care.